Hi, this is John Coronado on behalf of JCSE, and this is a session in Bridging the Gap. So for those of you who are not familiar with sessions of Bridging the Gap that we have at our office, take a look at our channel. Take a look at the JCSE LLC channel on YouTube. Take a look at the introduction, and that should help you quite a bit in terms of understanding what these sessions are about, what we've covered, what we hope to achieve with them. So should be helpful to you. But with that said, let's just jump into the current session here. The title for this particular session is W6-1. It is a shear panel detail, and we're going to discuss a shear wall line. So the idea is, what is meant by a shear wall line? Okay, well, fair enough, valid question. What is meant by a shear wall line? It's a term that you kind of frequently hear amongst engineers. So let's take a look here. Let me see if we can zoom in a little bit. And this is a representative roof framing plan. It's a plan view. For those of you who are not familiar with a plan view, maybe you're still early on in school, you might refer to these as top views. Okay, so in your graphics class, what they refer to as a top view is what in the industry we refer to as a plan view. So we're looking at a plan view, a top view of a roof framing plan. This is a roof framing plan of a project that we did recently here in the office. So let's go over this so that we understand kind of what we're looking at before we actually jump into some of the numbers, some of the forces involved, some of the connections involved that we do in these. So in particular, okay, roof edges. Well, these green lines here that you see across here, that's the roof edge, okay? This plan is truncated, okay? So this isn't the entire roof, okay? We're kind of truncating it here, but it's a portion of the roof. The ridge line, okay? So there's a ridge line across here, and that's the ridge line, okay? So I'll leave that in red. You know what? I'm gonna leave that in red, and then in yellow, I'm gonna draw again the roof edges. So this is the roof edges, the red line, yeah, the yellow line extends below here, right? And then the red line is a ridge, right? So we've got a fall in this roof from this ridge line down to the eave, which is at the top of the screen. Roof framing, okay, the roof framing, I'll use another color here. The roof framing is illustrated by these kind of lines with a half arrowhead, if you will, at the end. That represents roof framing. Whenever you see something like this, and different offices will show it slightly different ways, but when you see a line symbol with an arrowhead at the end, more than likely that means repetitive framing. So if you then look at the specification, in this case, what that says is new manufactured trusses at 24 inches on center. So whenever you see this kind of arrowhead at the end of the line, probably means repetitive framing. And then you read the specification and that'll give you an idea. So here what we've got, let me use dark green. What we've got is trusses, okay, trusses that are going, that are spaced 24 inches apart. Okay. So you're gonna have a whole bunch of these guys 24 inches apart and so on, right? That's what this arrowhead, this half arrow represents. All right, let me clear the screen. Now let me get into bearing walls. Okay, so what are our bearing walls here? Well, a bearing wall means a wall that is supporting weight other than itself. So it's got elements that frame into it. Well, in this case, we just saw that the trusses go in this direction, right? Trusses are going in this direction. So yes, they are landing on this wall, which I'll show you in blue. They are landing on this wall, and hence that wall supports the trusses. Hence that wall, I'll remove that blue line now. that wall that's represented by the double red line, right there and there, that wall is a bearing wall. Contrary to, and I'll use yellow, contrary to this wall here. Oops, I don't want to do an arrow. Just do a line here. This wall here is a non-bearing wall. This wall here is a non-bearing wall. The trusses do not bear on those walls. Okay. Now, don't want to get too much into this. Because they're not bearing walls doesn't mean that they're not important, and it doesn't mean that they're not structural. On the contrary, those are very important walls, and they are structural walls. They are shear walls. They are the ones, those walls that are in yellow are the walls that resist your lateral loading in this particular structure. So just because it's not bearing doesn't mean they're not important. But in this case, they are not bearing walls. The yellow walls are not bearing walls. Now, interior non-bearing walls, those are a little bit trickier. If you are designing the structure, then you have freedom as to which walls you decide to make bearing walls and which walls you don't. If you are not designing the structure and you're evaluating the structure, then you have to basically look at the wall and see how it's connected at the top and bottom so that you can make the determination whether the wall is bearing or not. Now, in this case, I know that we made these walls to be non-bearing. Okay, so these are all of these interior walls that you see here are not bearing. But you kind of have to know that. Again, that's not an automatic. All right, all of those interior walls are not bearing walls. Okay, so that's what we've got in this plan view. Let's scroll up. So what, okay, getting back to our question, what is a shear wall line? Let me see if I can split the screen here. Yeah, I've been able to split the screen here. So what is a shear wall line? Okay, a shear wall line is an imaginary line, okay? It may or may not have a kink to it. Okay, we'll cover that in a second. The line is the resultant of an extending a shear wall on each side until reaching the edge of the structure. Okay, in this case, this is a shear wall. Okay, that is a shear wall. Well, by definition, on how we're defining a shear wall line, it means that the extension of the shear wall to the edge constitutes a shear wall line. Sorry. So from edge to edge, bounded by a shear wall, did I say that right? I think so. From edge to edge of the structure, if you were to extend a shear wall all the way out to the edges of the plan, then that constitutes a shear wall line. Now let's take a look at, now let's just say hypothetically, we wanted to make this be a shear wall. Okay, we could do that, right? That's our shear wall. If that's our shear wall, then what is our shear wall line? Well, let's draw a line. Use light green, through this wall out and extended to the edge of the plan. So now all of a sudden, this here becomes the shear wall line. Now let's take a look at an interesting situation here. Notice this wall here, right? Notice how that wall is not quite in the same line as our yellow wall, the wall that we're saying we want to make our shear wall. So does the line that we're pointing to, does the wall that we're pointing to, does that become part of our shear wall line? Can we make it part of our shear wall? Is it part of our shear wall line? Excuse me. Well, the answer is yes. That's where this part of the definition, that's where this part of the definition comes in, with or without a kink. So therefore, what we're saying is that this wall here, followed by this kink with this wall here, that's all part of a shear wall, the same shear wall. That is all part of the same shear wall. That is all part of this, what we would call a shear wall line at this point in the structure. That's a shear wall line. Now, what if, oh, you know what? I think I can do this. Well, not really, but that's okay. We can ad lib here. All right. So what about this? Can this be part of our shear wall line? This wall here, and this wall here, right? Does that constitute, let's say, a shear wall line, I don't know, across here? Well, as you can see, a shear wall line is kind of a judgment call, but I would say no. I would say this is not a kink, right? This is not a kink. For you to do this and then drop down here and pick this wall segment up and then come back up here and say that's a kink, that's one wall, bit of a stretch, right? That's a bit of a stretch. You know, this one here and this one here, yeah, that flies. But the one that I showed in maroon, kind of a stretch, right? So you can see that, yes, there is some judgment in what we would refer to as a shear wall line. And yes, it probably helps to have done this a few times for you to start getting a little bit of a sense on what a shear wall line is. However, if you want to go back to statics, a junior level class, right? If you go back to statics, think of it as a beam with multiple supports, right? So if you have a beam and you have a support here and a support here and a support here and a support here, you could say, yeah, sure, you know, this, even though this span is smaller than the outside spans, but yeah, I can see that, right? If we were to try to draw a moment diagram for that, you know, we probably would have something that would go probably like this, maybe. Okay, that would be your moment diagram there. Now, if on the other hand, if I told you that our beam, was supported here, 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 and here, you know, you probably would look at that and you'd say, you know what? These two are essentially the same support, right? The behavior of this beam is not going to change a whole lot by having two supports so closely spaced together. The moment diagram in this case is probably going to be something like this. And it really doesn't get altered by the fact that there's two separate supports in such close proximity as compared to the other two spans. That's kind of what we're looking at when we look at this plan view, and we look at it as a horizontal beam. we would be saying, well, you know what, there's a support right here and a support right here. So does the behavior of this diaphragm change a whole lot by having two supports that are spaced this far apart? And the answer is probably no, right? So yeah, I'm sorry, I meant to say this one and this one, because these two are in very close proximity, right? As far as the offset. So in reality, they are going to behave as the same support. Whereas the one down here is too far away and it won't behave as part of the same support. Okay, so this one here, let me use even another color. How about if I use what, green? This condition mimics more having two closely spaced but separate supports. So you would have to take that into account. They cannot be considered part of the same shear wall line. All right. So that's covering a shear wall line. Let's see. Let's scroll down and see if there's anything else that we needed to cover here. Many times a shear wall line, when engineers talk about a shear wall line, the reality is it can also be just referred to as a shear wall. They really are one and the same. So for instance, if we, since I haven't drawn on this, I'm not gonna delete what we have so far. If we look at this wall here as a whole, now you can see that there's some marks across here. I'm gonna underscore them in red, right there, right there, right there. So those are openings in the wall. Could be doors, could be windows. Those are openings in the wall, but it doesn't change. It's still a shear wall. It's a shear wall with some openings, but it's a shear wall, one shear wall line. Um, so, so a shear wall line and a shear wall really are synonymous. That's, I think, kind of the point that we're trying to make here. Now we need to differentiate between the shear wall or shear wall line, which again are basically fairly synonymous, and a shear wall pier. That is an important distinction because these, now let me get rid of this. The shear wall piers are the individual wall components that constitute the shear wall or shear wall line. So in this case, this is a shear wall pier. That length of wall that's bounded by openings is the shear wall pier. So in this case, we have, well, you know, I kind of missed one here. Let's say we have 5. So we have 5 shear wall piers for this shear wall, right? This exterior, it's the exterior wall at the edge of this roof. We have 5 piers for that shear wall. Sorry. Here. So yes, a shear wall line can be composed of one or multiple shear wall piers. So in this case, this shear wall line has 5 piers to it. You could make the argument that you could ignore this one because it's so small, but we'll get into that later. Also, let me clear the screen here. Let's assume this wall were not here, all right? So now we're looking at this as our shear wall. Okay, so that's our shear wall. It's also our shear wall pier because there's no openings in that wall. So it's one pier. So the one pier, in this case, the one pier constitutes the entire length of the shear wall. And this would be the shear wall line, right? Again, the shear wall line is what we refer to as an out-to-out fictitious line through the shear wall, but going to the outer edges of the plan view. So the yellow for this shear wall, the one in red, the yellow line represents the shear wall line. And the red is the one shear wall pier. Okay, so hopefully that's clear. So identify piers 1 through 5. We've already done that. Well, not really, right? I guess I can draw that in. So I think we can call this 1. All right, we can call this pier 2. This one would be pier 3. This one is pier 4. And this is pier 5. And I think this becomes important in some other bridging the gap sessions that cover some of the other aspects about this shear wall design. And I think that's as far as we wanted to get in this session. So take a look at other related bridging the gap sessions for this concept. This one, remember, was entitled, what did we say? This one was, clear this. I think we said this one was W6-1. So other W6 sessions will cover other related concepts. So look for those on our channel. You'll see some of the other sessions will cover what's a shear wall line. I'm sorry, this one covers what's a shear wall line. The others will cover determining the forces in a shear wall assembly, how to determine the capacity of the elements, the connections of the assembly. So again, that'll all be in related sessions under the W6 in the W6 sequence of bridging the gap sessions. If this was helpful to you, sure would appreciate a thumbs up. Subscribe to our channel, JCSE LLC. Just hover over the JCSE logo. You can click on subscribe, and that way you can receive notifications when we do post new bridging the gap sessions. Okay, guys, real good.